Hello everyone, welcome to the third part of BellaDati Frontend Extensibility webinars. My name is Ondrej Hladík, I am developer at BellaDati, and today I will show you how to create a custom 3D visualization using a JavaScript library 3JS. So the goal is to create a visualization like this. This is a 3D model made in Blender, and on this model we will visualize data that we will get from BellaDati. So in this example we have a model of a track, and each square on the side of the track represents some impact of the cargo, and these impacts are also they are different by their color, which represents the strength of the impact. So I'll show you the whole process of how you can create a custom visualization like this using the data from BellaDati, and how to create this visualization inside of BellaDati in BellaDati extensions. So at first I will show you the data. I have here a data set, and in this data set are two attributes and one indicator. So each row represents one impact of the cargo. I have here two coordinates, so it's a position X and position Y, and the strength of the impact. Now I have generated these data and I'll show you how it will work. This is the model in Blender, and impacts will be visualized on 4 different sides of the track. So it's the left side right here, the rear side, the right side, and the front side. Now these coordinates they represent the position on the side of the cargo area. So if I have some impact on this position, on the position with coordinates like this, it will be somewhere here, somewhere on this left side of the track, because I have before I created this, I have had to think about it, how to create it. So the coordinates, how they work, it's that on the left side of the track, near this edge is like the beginning of the coordinate system, and moving on the left side of the track, moving on the left side of the track, moving on the left side of the track, one coordinate increases this way, and when it reaches this edge, when this coordinate increases, it linearly increases the number. It linearly increases, like it would kind of advance this way, like it wouldn't turn in the right angle. But when it reaches this threshold, in the code it will somehow compute that the impact will be on the rear side, and when it reaches another threshold it will be on the right side, and finally when it reaches this threshold it will then be on the front side. So the coordinates of these impacts they begin on the left side of the track on this edge. Okay, so these are our data, and to get this data I have created a chart view from where I will get the data using Ajax call. So this chart, it doesn't mean anything how it looks like, but when I open this, you can see here the response, and I will show you how it looks like. Okay, great. So the chart that I have created is a scatter chart, and in the JSON response which I get from this chart, I can see that I have some elements array, and in this array are some objects, and each object represents one impact. So I can see here that this is the X coordinate, this is the Y coordinate, and this number represents the strength of the impact. So I have the data for all the impacts in this form, which I will use to create the visualization of these impacts. Okay, so now I will tell you something about the object itself. So when you will be creating this custom visualization, something similar. So you will create some object that you will want to use to your custom visualization. You have to create the object, and then you have to somehow export it to and later use it in the browser. So in this example I am using Blender, and I have this object here. Now to import it in the browser in BellaDati extensions, I will export this model. So here in File, Export, and there you can see that there is 3JS option which will export the model to JSON. So here the important thing is that I want also the texture to be exported. So I will export this model, and what I will get are two files. I will get the JSON file which is the object itself, the mesh, and I will get some texture file. So in this example it's a PNG file. Now I have all that I need to import this model in the browser. So you can see that there are 3 JavaScript libraries or files. So there is the 3JS library, there is orbit controls. It's from the 3JS library and it implements some camera and controls. And here is the JavaScript that implements importing of the model and texture and the custom visualization of impacts. So I will show you the code here. So from the beginning, you are setting the scene camera and renderer, and then you are setting up the scene. So there is created a scene, there is set the width and height according to the window dimensions. There is created renderer. There is created camera. Interesting thing is this. There's the position of the camera. So as I will show you. This is the default position of the camera. So there are 3 coordinates. So on these coordinates, it's like when the user opens the page, the camera is on these coordinates. Okay, here's event listener that handles the resizing of the window. So as you can see, when the window is resized, the scene automatically changes the dimensions also. Okay, so this is the beginning, and here begins the part which loads the data from BellaDati, which I will skip for now. So it's from there it gets the data, and there it places each impact. I'll skip this for now. I'll continue with the setup of the scene. So here you can see two lights, because if there wouldn't be a light in the scene, there couldn't be seen anything. Okay, and here is the interesting part about the model and texture. So you can see that there is used JSON loader from the 3JS library, and we are loading 2 files. First, we are loading the exported mesh in the JSON, from which we get the geometry, and then we are loading the texture file, so from which we get the texture. So there is set material with some set material, and for the map is set the texture that is get from this file. There is set some metalness, and the mesh, there's constructed a new mesh with the geometry from this file and material that uses the texture. So there is set the position of the mesh, and there is the mesh added to the scene. Now there are some 3 coordinates where the model is set, and I'll show it right here. I have said that the impacts will begin on this edge on the left side of the track. And what I have done, I have made this edge to be the beginning of the coordinate system. So when I place the model in exactly these 3 coordinates, this edge will be in the beginning of the coordinate system. I can show it right here. If I uncomment this. Okay, so you can see the coordinates, and here you can see that on the green axis is exactly 1x. So here is the beginning of the coordinate system, and so the coordinates of each impact will begin here at 0, and with increasing value of this coordinate, it will move here. Now, when the value of this coordinate reaches this threshold, it won't continue this way, but it will be calculated to move in another direction using another coordinates, and so on of the next sides. Okay, and there in the end are edit controls, and also there is a control target. So it's like it's when you press the left mouse button, you are orbiting the camera about this point, which is set here. And this is like the rendering of the scene. Okay, so this was it all, and I'll go back to the part where I load data from BellaDati and I visualize them. So I'm getting data from this chart, and you can see that the response, I'm getting values from this tip. So this is the first coordinate, second coordinate, and the strength of the impact. So I get this tip, split it, and then split it again. So I get the first coordinate, second coordinate, and I don't get here. I'm not storing the strength of the impact, but the colors, because I have already in this chart created in the indicator, in the strength indicator, I have created conditional formatting. So there are set three colors based on the strength of the impact. So I'm getting these in the response. So here I'm storing the color, not the strength. Now this was the creation of the data array which stores all the data, and here I'm creating each impact on the side of the truck. So I get the X, Y, and Y coordinates and the color. And now you can see that the X coordinate, as I have set it, it goes like from, I'm not sure, but let's say from 0 to about 32. And if I moved from 0 again, if I move from 0 here to 32, it will be from here to somewhere there, maybe, where I'm pointing with my mouse. So you can see here that the length of this edge is 13.68. So when this coordinate of the impact will be greater than this, then the position of the impact that I will want to visualize will be different. So the coordinate will be, let's say, 15, but it won't be shown here, but it will be here. So this is handled here because I have here 4 functions, and each function places the impact on the correct side of the track. So each impact is represented by a square, as you can see. So I'll show you how the square is created. So I pass to the function the x position, the y position, and the color of the square. Now this is a plane in 3JS, so I'm creating a plane. There is set the size of the plane, size of the square. You can see that it will be 0.3 by 0.3. Here I'm defining the material with the color. You can see that it is transparent. And here I'm setting the position. There is one interesting thing. I'll show it right now. You can see this is the left side of the track, and I'm setting 3 coordinates. X and Y I get from BellaDati, from the data that I got from some sensor, for example. So these are these 2 values, but the third value should be constant, which is this, but here I'm decrementing some value, and I will show you why I do it. So if I remove this, it was the left side of the track. Okay, so you can see that these sides are okay, but this is the left side of the track, and you can see the flickering, because how I have created this custom visualization, I'm placing a plane, an object for each impact, and when these objects are too close to each other, basically they are interfering, you can see that there is some visual flickering, which doesn't look good. Even when it is not in the motion, you can see that there might be in the static picture some lines or something. So what I've done, I have, you can see here that I'm incrementing or decrementing some small values, so each plane will be further from the track. So as you can see, it goes it goes further from the track, the higher the plane is. So from the back, from the side, it looks bad, but the pro, that's the con. But the pro is that you don't get the flickering, and when you are looking from a greater distance, the fact that it gets further from the side of the track, I think it's better this way than if there was the flickering. Also there must be a better solution for this, maybe. I guess this was like the first solution that I got. So okay, you can see here that when I'm placing the plane on the side of the track, in some cases I'm rotating it, so you can see that when it is on left or right side, it is rotating by this value, but when it is on the rear or front sides, it's not rotated. So these planes are displayed right like this, but on the back it has to be rotated because otherwise it would look like these. Okay, so I think this is all for this visualization. Now there is time for your questions. I already got some, so you can ask if you want to, but yeah. Okay, so the first question is whether I have some other example of this custom 3D visualization using the 3JS, for example. So, well, I have here another example of this track, but the previous demo was created by generating some random data, and in this example I will show you a showcase how to make a kind of live 3D visualization. So this model gets data from this report, which is based on this data set. Okay, and I will show you the code, and it's the same as the previous, but there is some function that checks for the changes in data set. So when data in this data set are changed, the model will be lively updated. So I'll show it to you on the right side. So you can see that there are 4 impacts, and here I'm gonna take the data set and add record. So it's the right wall. Okay, so you can see that there are 4 impacts, and if I add this impact, it shows right here instantly. So this is kind of a showcase of some, for example, IoT solution. So I think it needs to be highlighted that this is some example, but you can do basically anything with this, especially as some kind of IoT solution, because data from you can get data from sensors, and in this example is based on a case which uses some sensors, and again you could be getting data from, I don't know, brake sensors or tire sensors, and you could visualize them in this example on the tires or brakes. So you could set some color of the tire based on how well it is and so on. And I'll get to a second question, which is about which is if there is a better solution to create a visualization like this, you know, from a lot of data from some sensor. So like for example in 3D, because in this example there are like 800 impacts, so there's rendered the track with the texture, but additionally there are rendered also 8 planes, and on personal computer it might be okay, but for example on mobile devices or notebooks the performance is more valuable. So there are for sure some ways to optimize it. For example, this case might be, I don't know, for example, if you took all these data and created some heat map, so it would look similarly to this, but from this heat map you would create a texture which you would put on each side of the track. So you would generate 4 textures and put it on each side of the track, and so this solution it might be, you know, resources consuming for the creation of the texture, but once it's done, the visualized data are just textures which aren't demanding on the, you know, on some hardware specification of the client. So this might be better for the performance. Okay, I think that this is all for this webinar. So thank you for attending this webinar, and I'm looking forward to see you again. Thank you. Goodbye.